I'm representing the National Seismic Hazard Modeling Project of the USGS, so I tweaked the assigned title on the slide to National Seismic Hazard Model. You'll see a lot of maps, but it's not the only product that we produce out of that product or project. So I tried to stick with the theme of the conference as a whole, the what's new, what's next, and with the limited time, I'm going to focus on kind of 4 topics each. So for what's new, I'm going to give you a little bit of information on the 2014 National Seismic Hazard Model, so new since the last time this conference was held at least. Talk about some of the uses of that updated model, primarily by engineers. And then also talk about some new products for the public. There's not one public, so I put that in quotes, that are derived from the National Seismic Hazard Model. Give you a little bit of information on the 2016 Central and Eastern U.S., that's the CEUS Seismic Hazard Model that includes induced seismicity, although you'll hear more about that after the break. And then for what's next, just talk quickly about validation of that 2016 hazard model that includes induced seismicity. And you'll probably hear more about this big question mark of whether there will be a 2017 update of that map. Project 17 is something that will be talked about later in the conference in more detail, but I'll give you a little bit of information on Project 17. It's a building code effort related to hazard modeling. And then give you a little info on the next update of the National Seismic Hazard Model, which will be before 2020. We haven't put a date on it yet, but we know it will be before 2020. And then touch on one topic just as really an example of new things that we're trying to do within the hazard modeling project at USGS and this urban hazard modeling topic that Tom already talked about a bit. Okay, so let's start with kind of what's new. So the USGS has been producing national seismic hazard models since the 70s, but really kind of the modern versions of those models started back in 1996 with Art Frankel. So a model developed and published as a USGS open file report. Then we updated that model about every 6 years. So there was a 2002 update of the national model, a 2008 update, and our most recent is the 2014 USGS hazard model. So the newest model is documented in a free USGS open file report, but it's also probably in more detail documented in a special issue of earthquake spectra that came out at the end of last year. So I put that graphic up there. Right. So this 2014 National Seismic Hazard Model, there were a lot of improvements that were made in it with respect to 2008. And so here's the whole smorgasbord of those. But I've tried to highlight a few improvements that are probably important for people to know about. The first, say, within California, with regards to earthquake sources, so the faults and other sources that produce earthquakes, how frequently they produce earthquakes, and how big those earthquakes are. In California, there's the Uniform California Earthquake Rupture Forecast version 3, so USERF 3 that Tom Jordan mentioned. And that took an important step of really recognizing more multi-fault ruptures that have been observed in the past, as well as taking care of a problem that's kind of nagged hazard modelers for a while, that our previous models tended to overpredict the frequency of mid-magnitude 6.5 to 7 earthquakes. And so that USERF 3 project really took steps forward in that respect. In the Intermountain West and the Pacific Northwest, there were kind of a lot of improvements made. Each of these bullets is an improvement. I'll mention the working group on Utah earthquake probabilities that brought new data to the problem and new analysis of that data. So much that, in fact, the Wasatch Front in Utah around Salt Lake City is probably one of the places where we have the most data about earthquake recurrence. And then in the central and eastern US, there is a central and eastern US seismic source characterization for nuclear facilities project that was folded into the USGS National Seismic Hazard Model. That, like the other efforts, were multi-year efforts with tens of experts on each of those. Okay. And then with respect to the other part of hazard modeling, not just the earthquake source characterization, but the ground motion characterization, how ground motions propagate from earthquakes of a certain magnitude with distance. There are a few projects that also led to improvements in the hazard model. As was mentioned, the Pacific Earthquake Engineering Research Center, Next Generation Attenuation for Western US, version 2 of that. So NGA West 2 is the acronym there. Again, bringing more data from earthquakes that have happened more recently and kind of a reevaluation of what was done in the NGA West project approximately 6 years back. For the subduction zone area up in the Pacific Northwest, there was a BC Hydro ground motion prediction project as well that was utilized. And then in the central and eastern US, as we'll find out later, we're still waiting for our big update there, but there was some work by the Electric Power Research Institute to look at the ground motion models that we have at this time and figure out how to best weight them to match the current data that we have. All right. So that's all I'll give on kind of the scientific technical aspects of this latest 2014 hazard model update. And I'll talk a little bit more about kind of the uses of those, the impacts of those that are new from this new model. All right, so where I went to college, you were either a techie or a fuzzy. There was no in between, like on this scale. And I think it works to kind of characterize or for us to think about our users in this sense. So we have users of the National Seismic Hazard Model that are seismic hazard modelers themselves. So some like folks that do insurance risk modeling, they're also modeling the hazard in that process. We have users that may not understand all the science, but they do use it very intimately, like earthquake engineers that use the hazard model for building code purposes. And for these kind of more technical users, sorry, I'll get back to that. So we also, a user group that we're trying to engage a bit more is emergency response planners, like people that would more typically use HAZUS. And it's really a group that probably the hazard modeling project hasn't interacted with as much in the past, and I think we're appreciating that now. And then the public as well. And there's not one public, but we often are contacted by the media about these hazard models. We have lots of people that come to our website looking for information, and so we want to pay more attention to those fuzzy users as well. So the more technical users, those top two, we held a workshop last year, the ATC USGS Seismic Hazard Users Needs Workshop, to try to get more engagement there and feedback on the projects there. And then with respect to kind of the fuzzier end of the scale, there's this emerging collaboration between the National Seismic Hazard Modeling Project and the USGS Science Application for Risk Reduction Project, SAFER, as well. So I'll give you a little information on that. All right, so historically, one of our primary users of this national model has been building codes. Right? And I would give you a little bit of information on how that works. So on the left, there you see the USGS National Seismic Hazard Model. So that's the scientific basis for the maps that eventually end up in building codes that show earthquake ground shaking amounts. Kind of how you take that national hazard model and make this map that's shown here, which is the map that is now in the process of being adopted into the International Building Code, the 2018 edition, which then would be adopted by places like California after that. That process is really defined in something called the NEC's recommended seismic provisions for new buildings and other structures. So it says, how do you take hazard information and turn it into a ground motion that you use for design? The group that develops that process, that derivation process, is really the Building Seismic Safety Council, in particular their Provisions Update Committee that does their work with some funding from FEMA and support, of course, from the USGS as well. And so that combination of efforts ultimately leads to the ground motion maps that we have in our building codes now and that are being updated for the impending building codes, and they're called these risk-targeted maximum considered earthquake ground motion maps. Right. So with this 2014 update of the National Seismic Hazard Model, we also updated the building code maps. And this is a figure that just sort of shows the quantification of how much things change. So we got 34 different city locations along the bottom. These are all high-risk cities, so either high hazard and or high population cities. You can see their regions there. And then on the y-axis, I'm just showing the ratio of the mapped ground motion value that comes from the new model, the 2014 model, divided by the mapped ground motion that was derived for building codes from the 2008 USGS hazard model. And then there are some dashed lines there that kind of show plus or minus 10% and 20% increases. So if you squint at this thing, you can kind of see that for maybe about 2/3 of these locations, the values are within plus or minus 20% out of the new USGS model compared to the last version of that. Well, actually 2/3 are probably within plus or minus 10%, almost 90% or 9/10 of them are within 20%. And you can kind of see also, and this will be important later, that a lot of the values are reducing a little bit with respect to unity here. There are a lot of points here. So but the outliers are the ones that are important to point out. So you see like in Irvine, San Diego, Santa Barbara, Las Vegas, Charleston, you'll see either bigger or smaller changes compared to 20%. And that's where kind of the new science really has an impact, right? If you didn't have much change, maybe building codes wouldn't really need to change things to really affect safety. But in some of these places like Las Vegas, where now we think the hazard is significantly higher than it was before, it's important to account for that in new building code documents. All right, so that's building code use. Engineering risk assessment groups use. So they're risk modelers that make use of this national hazard model to do lots of insurance-related risk assessments. I'm just going to mention a couple things that were done within the USGS and that are relatively simple. We have kind of a sister project, an engineering risk assessment project that worked on a couple of things here, in particular Kishore Jaiswal. And there's a paper in that Earthquake Spectra on this topic. So first thing Kishore and a group of others did was to look at the hazard map, translate it into MMI, intensities that are a little bit easier to understand than acceleration G's of ground motion. And then looked at the population exposure on top of that. So this is really the map that leads to the statement, I think, that was on the assigned title, which was that more than around 50% of the population is exposed to damaging earthquake shaking. And that was really done by looking, gotta go back. At intensity 6, which is kind of the beginning of slight damage. And you see the areas that are kind of in yellow or hotter colors, and a lot of the population is in that area. This 50% number didn't change a lot with respect to the 2008 USGS hazard model, but this type of analysis exactly wasn't done before, only retrospectively. And then another engineering risk assessment use was to take the USGS National Seismic Hazard Model, the HAZUS software for estimating annualized earthquake losses and scenario losses as well, and to update essentially a document that FEMA has produced in the past, and this time USGS with colleagues in FEMA and others did. Again, Kishore Joswal, I showed the paper there. And so the conclusion from this, and here you can see a map of kind of these annualized expected losses, which a total over the US is about $4.5 billion per year, most of which is in California or at least in the West. And so you can build on the hazard model and get these kinds of results. These numbers changed a little bit with respect to the 2008 USGS hazard model. Actually, these numbers are about 10% lower. And I think that is consistent with kind of that plot we looked at earlier, where in a lot of places the ground motions are going down a little bit in 2014 with respect to the 2008 USGS hazard model. Okay. All right, so public use, and we've had kind of building code use, engineering risk assessment use, public use. We're trying to pay more attention to this with respect to our hazard model. And so Sue Perry from the SAFER project that I mentioned with some social science colleagues has really worked with us to develop a website that is more useful to the layperson. And so here's just the beginning of that introduction. It talks about even things like what's the difference between hazard and risk. A lay description of what are the USGS National Seismic Hazard Maps. And so we're working to try to provide that more useful information. Included in that website is a map of hazard that looks a lot like the other maps of hazard that you may have seen. But it presents information in a way that we hope is more useful to the public. Right? Primarily, our maps have been ground motions, spectral accelerations, quantities of G that are difficult to explain to the public, and that's because our primary users have been building codes and engineers. But now we're trying to show a map that simply shows how often does damaging earthquake shaking happen across the US. All right? And so this particular map says, how often do we think we see MMI intensity 6 shaking across the US? And then a lot of our new website goes on to explain more about this map and what it's useful for and what you can't get from that map alone. All right, so on this figure here, or on this map here, it's hard to notice, but you see these little black boxes in certain areas. This map and all the maps that I've talked about so far, in fact, the 2014 National Seismic Hazard Model, purposefully excluded the induced seismicity, this oil production, wastewater injection induced seismicity that we've been observing in places like Oklahoma recently. So, and that was purposeful, and I'll talk more about why that was. The plan was always to come back and look at that induced seismicity, and so that's what's been done recently. So there's a 2016 USGS hazard model primarily for the central and eastern US that includes this induced seismicity. And it's just a one-year forecast. So looking back just over the last couple of years, what's been happening with induced seismicity, and then trying to project what's occurring in the next year. And you'll hear more information on this in the next project after the break. So I'll go ahead and just talk a little bit about uses of this induced seismicity hazard model. So again, back to engineering risk assessment. This is a boring map that shows the collapse risk that we estimate for new buildings, so built to kind of current code, or at least recent code, or retrofitted to current or recent code, if you don't consider induced seismicity. Right? And so most of this map is one color because that's what the building codes now are trying to do. They're trying to set the standards so that we have about the same risk of collapse of individual buildings in different parts of the country. But there are places on this map where the risk is a bit higher, and that's in California, because building codes not only consider probabilistic ground motions, but they look at deterministic ground motions around big faults like the San Andreas, and in many cases use those to cap what you see, what you would get from a probabilistic analysis. And that capping, that limiting of the ground motion for design means that you would have buildings that are a little riskier. Right? So we have a little bit higher risk in California. So if you make a similar map here, again, this is a new building collapse risk, so chance of collapse in 1 year is what's plotted here. If you make the same map now, including induced seismicity, you see collapse risks that are very high and higher than what we saw in the deterministically capped areas of California. Right? So, and this is just because of the huge increase in the frequency of earthquakes in this area. And so this is a real, if we really believe that our risks have gone up this much in terms of buildings collapsing, it really is a motivator for some sort of mitigation. And we're starting to see that, right, with regulations on this wastewater injection and such. So, we work a lot with building codes, and so often without thinking, people will say, well, the first thing we would do with that induced seismicity model is put it into the building code. But there are a lot of issues with doing that, and I'll just quickly kind of go over a few here, right? So this induced seismicity hazard is potentially transient, right? And especially when you compare it to the lifetime of typical buildings that we're concerned with, or the 50-year lifetime. So this induced seismicity, it's already something that looks like it's starting to slow down. It may change in the course of years potentially, or even if it's a decade, that could be shorter than respect to a building's lifetime. The other issue we have is just the length of the current process of updating the seismic provisions in building codes. So that's done about every 6 years relative to the changes in induced seismicity. So right now we're seeing that you could quantify the hazard from induced seismicity on an annual basis and see that change much more quickly than that time period in which you're trying to incorporate it in a code. So you need a new process. Not that that couldn't be handled, but you need a new process. There's also the question of who shall incur increased costs for designing against induced seismicity, right? So if you were to put new ground motion maps in building codes that include induced seismicity, you'd essentially be specifying who is, without further discussion, you'd be specifying who's paying for that, right? Building owners who are paying for their structures that use the design code. And so at least that needs to be discussed. The trade-off in those costs between building owners versus oil producers. And then, engineers will always bring up, I'm one of them, but I hang out a lot with my earth science buddies, just the uncertainty and the probability of large magnitude induced earthquakes, right? So we've seen some pretty big earthquakes, but like really large, like bigger than magnitude 6. We haven't seen that yet. A lot of the scientific thinking is, well, we haven't seen it yet because it wouldn't happen very frequently, but we think it really can. It's hard to know until we have more time to look at this problem. All right, so to get to then sort of the what's next topics, I'll move through these more quickly. So that induced seismicity hazard model, one of the next things we want to do with that is to try to validate it. It's an interesting situation where since we have many more earthquakes that are occurring, at least of smaller magnitudes, it's something that we can test more than we've been able to with hazard models that are most interesting for the big magnitude earthquakes and strong shaking that don't occur as frequently. So we're going to do some validation against observed earthquakes, observed ground shaking, and observed intensities. And so for the intensities, this is a map I show that ties back to something that Tom Jordan mentioned the Did You Feel It website of the USGS, where people can report essentially the intensities that they've felt, and then just looking over a past year or two or several years. Well, in this case, it's looking just within 2015 at the Did You Feel It intensities that were reported in different parts of the country, and using that information to compare with what you would get out of a hazard model forecast. All right, so we want to do that validation. Project 17, I'll talk about this more in the afternoon, but sort of strange name. Project 97 was the first project that really started, that led to directly using the USGS National Hazard Model in building codes. Before, there was sort of a loose relationship between those. Project 07 kind of just revisited what was done back in 1997 and introduced kind of the new risk-targeted maps that I mentioned earlier. And then Project 17 is now a project that will propose new ground motion maps ultimately for the 2024 International Building Code. So we're just finishing up, kind of getting things into the 2018 International Building Code, and we're already starting on the next one. Project 17, it was motivated by negative votes during the adoption of the 2014 USGS hazard model. In that building code process, there were negative votes that I'll talk about more this afternoon. And then also, it's just, we had gotten in the habit of, on a 10-year basis, revisiting what we're doing in terms of taking the USGS hazard model and turning that into ground motion maps for building codes. It's a collaboration of the group I mentioned before, the Building Seismic Safety Council, BSSC, that has funding from FEMA and the USGS. And then with available funding, there's really 4 issues that this group is focusing on, and I'll only give brief descriptions of this now. The first is balancing changes and instability in the mapped ground motions that are in building codes with and also the precision that with which we use those ground motions with the uncertainty in hazard modeling, a big issue. There's a targeted risk of collapse. So this now is a 1% in 50-year target risk of collapse, that boring map that I showed. But there are questions about whether that's the appropriate target. That was chosen to be compatible with what we were doing in the code before, as opposed to really a conscious new decision. Multi-period and multi-VS30 ground motion spectra, so more technical, but it's trying to use more information from the USGS rather than sort of the limited 0.2 second, 1 second spectral acceleration values for a reference site condition that were used in the past. And then deterministic ground motion caps. So I mentioned that those are in California, resulting in elevated risk. Plus, they're hard to define nowadays with things like USERF 3, where USERF 3 challenges the notion of having characteristic earthquakes, and that's typically what the building code has used in the past for deterministic. The before 2020 National Seismic Hazard Model. So it's before 2020 because through the building code process, some of those negative votes were saying, hey, we just need more time to understand the impact of the hazard modeling changes on the ground motion maps that are in building code. So we're trying to do our next model earlier. And then because, especially that topic in the last slide of multi-period, multi-VS30 spectra, using more information from the USGS, we're really waiting on another peer Pacific Earthquake Engineering Research Center project called NGA East. So ground motion characterization for the central and eastern US. And so that's going to be a major component of the next update. There will be some other aspects as well, but that's the primary change that's coming down the pike for our next hazard model update. And then Tom, I knew Tom would be talking before me, and he would be talking about simulations and their use in hazard modeling. And he referred to this group that the USGS has now put together, or a working group on urban seismic hazard modeling. Right? So over the past decade or so, the USGS and others have worked on hazard models for specific areas. And they're shown on this map as dots, but they're really kind of regions in these areas. And these have been, in the past, relatively independent efforts, some of which, used simulated ground motions, like Tom talked about for the Los Angeles area. Something similar was done for Seattle, and something similar is planned for Salt Lake City. Other places, like in the central and eastern U.S., where the main emphasis was getting more information about soil conditions and their impact on seismic hazard. So this working group is really trying to come to a point where we can standardize these models more and also harmonize them with the national model, so that we don't have so many disparate hazard models that are all representing different things and aren't connected with the hazard model. So that's an effort that's just starting now, and I think our group in Golden works on the national hazard maps is a small one, and so we really do need to work with external folks, and this is one of the ways that we can do that, but we need a good plan for that effort. All right, so trying to give an overview of what's new, what's next with respect to the National Seismic Hazard Model. And there are lots of related talks that are coming up throughout this conference, but I listed here some that are, that I already touched on in a brief way. So look forward to these talks and providing more information on these subjects and ultimately the conversations and feedback that we get. Thank you.